Welcome to iLectureOnline, and our next segment in physics is two-dimensional motion, or motion in two dimensions. And in order to understand a little bit better, let's take a look at our example here. We have two objects, let's call them balls. One that's simply dropped from a certain height, and one that's thrown horizontally outward, also from the same height. And then the question, of course, is which ball will hit the ground first? And of course, the ground should have been flat, not quite. The answer is they will both hit the ground at the very same time. And sometimes that seems a little puzzling because intuitively we would think that this ball which travels a greater distance would take longer to hit the ground before the ball that just drops straight down. And the reason why that is not the case, the reason why they hit the ground at the very same time is because the motion in the x direction and the motion in the y direction, so the horizontal motion of the ball and the vertical motion of the ball, are completely independent of one another. Notice in the horizontal direction there's no forces acting on the balls, so this ball will stay stationary in the x direction, simply fall down in the y direction. This ball, once thrown out to the right at some initial velocity in the x direction, it will no longer feel a force in the x direction, and so the ball will simply maintain the same velocity in the horizontal direction. In the vertical direction, the y direction, both balls feel the exact same force. They feel the force of gravity. So on the left ball, we have a force due to gravity. And on the right side, we have a force due to gravity. So both balls feel the exact same force, assuming that they have the same mass. And so therefore, they're being pulled down or accelerated downward at the very same rate. You can see that the velocities in the y direction are the same at the same time interval. And you can see that therefore, they will hit the ground at the very same time. So what can we learn from this? Well, first of all, we should learn that the time in the air for ball number 1 is equal to time in the air for ball number 2. So that is really important. Later on, when we start doing problems and examples, that concept is extremely important. So the time in the air for any projectile, no matter what happens to it, only depends upon the vertical velocity and the vertical forces. Also, we should always keep in mind that the motion in the x direction, so we're talking about the horizontal direction, is completely, and I mean completely, independent of the motion in the y direction. Of course, that would be the vertical motion. So why did I take the time to write that down? Well, it's a really important concept. So in all problems I'm going to do with projectile motion, you can look at the horizontal motion and the vertical motion completely independent, as they have nothing to do with each other. The only thing is that the time in the air depends upon how long it takes for the object to hit the ground in a vertical direction. So let's now talk about how we describe the equations of motion in the two dimensions. So for the horizontal, since there are no forces acting on that in that direction, there's no gravity in the horizontal direction, we can simply say that the velocity in the x direction is simply equal to the initial velocity in the x direction, and it doesn't change. So whatever the initial velocity was in the x direction, it will maintain that velocity throughout its entire motion. Doesn't change. Notice that the arrow in the horizontal direction doesn't change. That represents velocity in the x direction. The distance traveled in the x direction is simply equal to the initial velocity in the x direction times the amount of time that the object stays in the air, which is determined by the vertical motion only. All right? On the vertical motion, the velocity in the y direction is equal to the initial velocity in the y direction plus the acceleration times time. And in this case, we can probably just say that the acceleration for a projectile will be, of course, the acceleration due to gravity, and that's a minus 9.8 meters per second squared. Notice that if it has no initial velocity in the y direction, then v sub y is simply equal to g times t. And for the position, we could say that y is equal to the initial position in the y direction plus v initial in the y direction times time plus 1/2 g t squared. And of course, that came from the equations of motion. So those are the two ways in which we look at motion of a projectile, horizontally and vertically, and we keep them completely separate. So there's a nice little introduction of how to look at two-dimensional motion and how we look at x and y motion completely independent, and that's the basis by which we're going to solve all problems for projectile motion.